All right. Okay. All right. Part 2 of the first assessment. I've got to actually find the worksheet. I'm running out of battery, so I'm going to stay back here on this wall. I think we got through problem 24. I hope I'm doing them all. So, well, if not, I'm getting most of it anyway. All right, so 25. 25. Minus 2x over 5 minus 4 equals x over 3 plus 1. If you ever see me write y, k, t, d, I'm communicating to you, you know the drill. Okay? Because a problem like this, I'm only after your first line of work. If you can crack your first line of work, then you're fine. So what I'm looking for is multiplication by 15, the correct multiplication, 3 times negative 2, negative 6x, minus 4 times 15, minus 60. 3 goes into 15, 5. 5 times x, 5x. And 15 times 1 is 15. You give me that, I'll give you that. All right? That's all I'm going to ask for. You got a lot of problems here. What do you live here, David?
Yeah.
I mean, I came in at 7 today, and I think you were already here. I don't know if it was 7, 7:30.
Yeah, I usually get here around 6. I start at 7.
Are you teaching 2 classes?
1, but it's like spread out over 3 blocks. So I go from 7 to 8:30, 9 to 10:30, 11:30 to 1.
Are you doing enough math right now that when you fall asleep, the numbers are still in your head? No.
As soon as I walk out the door.
You're good. You teach me how to do that, all right?
Yeah.
All right. Not for me. All right. I don't know about you folks, but I got numbers floating through my head at night now. All right. Now working with imaginaries. 5 minus 2i times 5 minus 2i. And we're looking at, excuse me, gotta sneeze. Oh, yeah. Rain got to me. So we're looking at the shortcut, but you expand it if you having any trouble with the shortcut. Squaring, doubling the product, minus times a minus, 4i squared. What does 4i squared do? It makes it negative 4. So negative 4, 25, 21. Excuse me, minus 20i. All right, so that's number 26. 26. That's what you get. You got that, you got that. You put something in your pocket. All right. Now we're on one more than 26. I think that's 27. Solve. 1 plus 3, 4, x minus 2 equals 7. I'm going to use inverse operations. There's another aspect of solving here that we can do as well. All right, but I'm going to do the correct inverse operation. So 3, 4, x minus 2, subtract 1 equals 6. 4, x minus 2 equals 2. X minus 2 is the value of the exponent that you put on top of a 4 to get a 2. I hope you see that x minus 2 is the square rooting exponent, 1/2. So your answer was x equals 2.5. All right? Now you also could have gone to this line of work right here. And you could have said, let me make sure you can see all this. Yep. You could have said, oh, same base. Well, 4 is 2 squared. And I'm raising that to the x minus 2. And I want that to equal 2 to the 1. Well, then that has to become the number 1. And we got to remember to distribute. 2 times x and 2 times negative 2. And that's got to equal 1. Boy, I'm telling you. I'm seeing something wrong here. All right, let's go back, check our work. subtract 1, divide by 2. I know x minus 2 has to equal a half, so that's true. That's 2.5. So 2 squared is 4. X minus 2 equals 1. Oh, this brain is tired right now. Oh, maybe you're seeing my error. I'm not. And my brain is so tired, I may not be able to figure it out because I need a nap. 4 is 2 squared. It's 2, so that's 2x minus 4 equals 2 to the 1. So 2x minus 4 equals 1. Yep. All right, so x minus 2, this was a 4 before. So exponentiating on this side is logging on this side. Log base 4 of 2 half, 2.5. Oh, you know what? That's how tired I am. I thought I wanted a half. It's 2.5. Nothing wrong here. So x equals 5 over 2. It's 2.5. I apologize. Yeah, I'm feeling like I need a nap. It's all right. Everything was right. All right. Let's hope that doesn't happen again. If it does, I'll make the video tomorrow, but I'll try to rally. I will try to rally. I've been up a long time today. All right. Happens to all of us. All right, it's cube root 54. Remember, the cube roots that are important are 8, 27, 64, and 125. Right, the cube root of 8 is 2, 27 is 3, 4, and 5, etc. So those are very useful numbers to know. And I hope you can see that if you divide 54 by 2, we do have a cube root embedded in that integer. X squared, y to the 12th, z to the 23rd. And just make sure you put cube root in your final answer. That's where people make a lot of mistakes. So I'm going to write 27 times 2. So the cube root of 27 I know. 3. I don't know the cube root of 2, so I'll do it this way. The cube root of x squared. Got to have at least an exponent 3 or bigger to work with it. So I don't change that. 3 goes into 12 4 times, right? Why? Because y to the 4th cubed is y to the 12th. So that's the cube root. 23 could have been written as 21 times z squared. I can't take that one. Z squared. I can't take z squared, but I sure can take 7 out here. Okay, and that's the simplification. Okay. That's that one. Now we're looking at 28. That was 28. Now we're looking at 29. 3x minus 2y equals 19. Through AB, x minus a plus b. Put in an a, you get a b. And we want perpendicular. So we know it's minus 2/3 just by looking at this form. We've seen the pattern. But let's work it out. So 3x equals 2y. We don't care about the constant. It has nothing to do with rise over run. So we divide by 2. And we have a function that it's going up at 3 to 2, something like that, a 3 to 2 ratio. 3 to 2, and the perpendicular is going down at minus 2 to 3, the reciprocal, negative, which was embedded right there. So there's your perpendicular. I haven't been writing y equals 3 years. I suppose you should. All right, so 30. I'm surprised nobody's asked me for more practice on number 30. I know from my classes that takes a while to learn. Well, let's do it. And the reason I do this problem is students come out of Algebra 1 not understanding what long division is for in algebraic context, and certainly not synthetic division. Not going to teach synthetic division, but I'll explain where it comes from and how it was used. And where it comes from starts here. X minus 3 times what? Gets us x squared plus 5x minus 7. Well, I know if I multiply by x, I get x squared minus 3x. I need to get to 5x. How do you get from minus 3 to 5x? You got to go up 8. And that gives me 8x. And that gives me x squared plus 5x. I'm headed in the right direction. But it gives me a new constant, negative 24. I don't want negative 24. I want negative 7. On a number line, I have to go up, oh, is my brain tired? 17 units. Now, that's how I'd like you to write the answer. And I hope you can see that after you do the foiling here, the x minus 3's cancel. That's what changed the constant. But I'm going to write it like this, because I'm going to show you how you can find out if you're right or wrong. I hope I wrote that well. I could have written this as x plus 8, and I could have put the remainder outside. Okay? Now, what is being stated here is the calculation on the left may be written that way, or the calculation on the right may be written this way. But if the calculations are equal, then their tables are equal. Every table value is equal. Critical number here is 3. When I put a 3 in here, I get a 0 times something. Well, that's 0. Parentheses times parentheses, 0. But plus 17 is outside the parentheses, so I get 17. If I don't get a 17 out of here, then I made another careless error. And I could right now, because my brain is about as slow as molasses. And I'm about to talk to my good buddy, whose brain is not slow as molasses. Wish me luck. All right, so let's do it out. Might as well find out if we're right. And if you're on a final exam, and you got all the time in the world, that's the time to be careful. 9 plus 15 minus 7. 24 minus 7. That is 17. I'm moving on. I hope this is recording. Oh, God help me. All right. I don't know what number we're on until I look at the sheet. I'll put it up there. Oh, a conjugate. 5 plus 2i over 7 minus 3i. Make sure I got that right. I have it right, and that's number 31. I should have a paper here and start putting this down, send it to you on paper, but not right now. Just got to get through. Parentheses, 7 plus 3i is the conjugate. That's going to allow us to get a real number eventually in the denominator. 7 plus 3i divided by 7 plus 3i is 1. 1 times anything, I still have the same calculation. All right, 35. 15i. 14i. 6i squared. 6i squared is going to become negative 6. So I'm going to take 6 away from 35. 29. Gonzo. 15 and 14 is 29i. Wow, 29, 29. I don't see that too often. All right, 7 times 7 is 49. Middle terms cancel, plus minus 4, minus 9i squared. 49 and 9, that's going to become positive 9. Sign change, 58. Wow, what's going on here? Because that's twice the size of that, so I can factor out a 29. So this thing actually becomes 1 plus I over 2. I guess coincidence that all those numbers seem so nice and round. I'm trying to see if there's a pattern here. I'll think about it later on my own time. All right, 5i to the 47th. Again, Your future math classes, I hope you always remember I squared is the number -1. All right, so we're doing 5i to the 47th. I'm going to work with I squared. And I'm going to use my rules of exponents to get back to 47. 23 gets me really close. I got to get one more in there. But I know that 5 to the -1 is it's an odd number of times that I'm doing that, times I. Whenever you multiply a negative an odd number of times, you get a negative. There you go. SAT question, achievement test question. I hope I'm on 32. Getting there. Let's get this out of here. Forget you ever saw that. No, only kidding. X squared plus 6x equals 11. You know, you always set quadratics to 0, but in this case, I hope you can see right from the get-go, you can't factor. You can't write that as a product. And if you can't write it as a product, then the easiest method of solution for quadratics goes out the window for most quadratics. So what do? The same stuff you do with a circle. X plus 3 squared minus 9 equals 11. All right, x plus 3 squared equals 20. X plus 3 equals plus minus the square root of 20. X equals -3, probably should say, square root of 20. Oh, I can't even write. Square root of 20 is equal to the square root of 4 times square root of 5. Probably should write 2 plus 2 square root of 5. Yep, that looks good. And we have been learning to go backwards, by the way. I think I gave that to you in another place on the test. All right, so that's that one. Let's go to 33. That was 33. Okay. I guess having done that, when I gave you the original problem, it brought to mind, all right, we've got x equals 5 plus or minus 2i. I hope that didn't cause you trouble. I meant to talk to you about that before you took the assessment. My computer doesn't do a good job of the plus minus. Okay, so when you see what you saw in the last assessment, that little long underscore, that's what I'm trying to communicate to you. Okay, and eventually I hope all right, so where are we going? Back to ax squared plus bx plus c equals 0. Your next challenge, if you get this right, is when you see it, see if you can do it in your head. All right, see if you can do it in your head. It's good practice for the brain. So we got to get 0. That means everything's got to come back. These answers come from squaring process. So it must have come from this. Must have come from that. This is x squared minus 10x plus 25. And this is 4i squared, which is equal to -4. I'll save a line of work because I'm getting in trouble here. I'm only so tall and I'm shrinking. I used to be 5'9". Last time at the doctor's, I was 5'8.25". Oh, x squared minus 10x plus 29 equals 0. There you go. Now I got to find the other sheet because I know there's more questions. Hang with me. I hope I find it. Oh, that'd be awful if I can't find it. Oh, come on. Where are you? Oh, wait a minute. Piece of paper fell off the table on the chair. And I found it, you little critter, you. Hiding on me like that. Yeah, whatever do to you. Problem 35. 35, yes. 5x squared equals 7x. Uh, 35. 5x squared is a pretty narrow parabola, but I'm going to widen it. And 7x is a line through the origin. I got a 0 and a positive number for answers. And I'm going to sneeze again. Oh, God, it's terrible. Nope, maybe not. All right, so how do we do this? Easiest way, make it a product. All right, because products set to 0 are fun. What's the first rule of writing products? Take out what's common. Is somebody else going to tell you to write it as a product? No. When you get to this line, how do you do it? They're going to say factor. I think we should say change the subtraction to multiplication. Then, what did I put that there for? Change the subtraction to multiplication, because then you can see what are your critical numbers. That's a 5. Ooh. Boy. So that was the 0. And this x right there, that x is 7/5. I might as well put it in there one time for you. 5 times 7/5 squared. And then this is 7/5. Okay. This is 5 times 7/5. What's going to happen to these 5s? They're going to cancel. And you're going to get 7 times 7/5. Because that's going to cancel with that. And so the height of this thing is the coordinate 7/5, 49/5, which is close to 10, right? 50/5 is 10. That's where they intersect. That's where they share table values. It's the only time they share table values. All right, that's what that's about. Ah, God. Hang in there, old man. I still got time to visit my buddy. Yes, he's coming to Zoom at 2. We did this one in class. Again, natural log. Natural log, actually backwards. Natural log is asking the question, e to the what gets us 6. So if I wanted to know e to the what gets me 99, I'd go to a calculator and I'd find the ln of x button and I'd plug in 99. And it would tell me. I want you to get a feeling. If you don't have a feeling for some numbers, you're never going to get a feeling for the calculation. So I'm giving you some user-friendly numbers off a calculator. And I'm giving you e to the 0.7 is approximately 2, which means that e to the negative 0.7 is the reciprocal of that. I should approximately, right? And I'm giving you e to the negative 1.1 is approximately a third. So e to the negative 0.7, I already gave. So e to the negative 1, I get that. E to the 1.1 is approximately 3. Right? Those are really good numbers to work with. All right. And e to the 0, of course, is 1. All right. So negative exponents are going to give us the base of exponential decay, and positive exponents are going to give us growth. Because 3 to the x is approximately the same as e to the 1.1x. That's a growth function. So any positive number is all about growth exponents. All right, what question did I? So we did this one in class. What gets me a 6? Well, I know that 6 is 2 times 3. 2 is e to the 0.7. 3 is e to the 1.1. So it looks like 6 is e to the 1.8 because you would add those exponents. You would add the exponent that on top of e that gives you 2. You would add that to the exponent 1.1 that gives you a 3. And that would give you the ln of 6. Geez. 2 times 3. 2 times 3. 6. Wow. I wonder what exponent gets me 12. I know 12 is 2 times 2 times 3. I know 2 is e to the 0.7, e to the 0.7, e to the 1.1. Looks like 2.5. I think I could add those up. Okay, we're going to build on that.
the whole term. I got to send you these values though. And it's not going to be today. Try to rally tomorrow. Hanging on for dear life. Oh, we're almost there. 4 graphs. How nice.
So, forget the number. You find it.
No, I'll get it for you. It's 37.
5x plus 3y equals 60. Y-intercept 20. X-intercept 12. There's your graph.
38.
Y minus 4 equals minus 2/3 x plus 5. When you put negative 5 in, the whole right side becomes 0. And 0 equals 0 only if you put 4 in for y. I think it's a whole lot better if you put the 4 over here as a positive. Then you can see this so much more easily. Okay, but this is called point slope. It's what the world works with. It got handed down and it's stuck. So we're stuck with it. Oh, we're graphing. All right, so I am going to move this over for my benefit. As tired as I am going to locate the point, negative 5, 4, negative 5, 4. I'm going to estimate it's there. And I'm just going to show the slope. Down 2, over 3. That's good enough. I mean, if you want to be cutesy, negative 5, 4, throw some points in there. Go up 2, go up 3. Negative 2, go up 3, go up 3. Fine, go down 2. Right? I mean, 1, 0, right there. Either way, you can show one point and another. I don't care. Just get the thing right. All right, next. Back side of the sheet. 4 more problems. 39. Because I'm so tired, I'm going to show you the shortcut for graphing this. I'm going to do it for all of them. All right. Minus 3x squared plus 12x plus 12x minus 5. Minus 5. I'm going to start at minus 5. I know I'm going up. And I know it's cup shaped down. Off kilter a little bit. Who cares? 3 goes into 12. 4 cut in half is 2. Minus b over 2a, you should have gotten 2. And if you put 2 in, you got 24 cut in half is 12 minus 5 is 7. I'm done. That's 0. So when you graph a parabola, I'm looking for the vertex and the y-intercept. All right, exponential function. Show you what I know. Show you what I know each and every time we do this. 7 plus 5 9/5. X minus 3 over 4. All right, what's coming out of this? Y asymptote is 7. My first jump is actually 5. My second jump is actually 9. What? 5 plus 7? You should have a 12 here. Happens when x is 3. Remember, 9/5 to the 0 is 1, so it's 1 jump of 5. 9 and 7 is 16. Happens 4 units later. Happens at 7. Oh, I hate the same numbers showing up anywhere when you're first learning. But those are the points. All right. Square root with a negative in front of it as a starting place and goes down. Negative 5 over root 7. Square root of x minus 3 plus 4. Square roots are distances. Smallest distance you can have is 0. What makes a 0? 3. If I put a 3 in, I get a 4.
That's happening in a lot of the functions we're studying. Square root of 7. Wonder how I can get the square root of 7. Oh, I think if I put a 10 in there. I have a feeling I'm going to go down 5 units from 4. But let's actually replace x with 10. 10 minus 3. That's the square root of 7. I wonder what happens to these numbers. Dividing, I think they cancel. And minus 5 plus 4, that is correct. Did I mention that square root's going to be on every test the rest of the year? I probably forgot to say that. 4e to the x minus 5 plus 6. So positive 6 should be a dotted line. It should be everything's above it, growth, because it's positive x, yes? Yes, I saw it correctly. So 4e to the x minus 5 plus 6. That's your first jump, 4 units. So I know this is 10, and that's going to happen when x is 5. 5 minus 5 is 0. What is 4e to the 0 plus 6? Well, e to the 0 is 1. What is 4 plus 6? By golly, it is my first jump. And I'm going to make the next one be 12, which takes me to 18. I wonder how I can become 3 times that. Oh, e to the 1.1 gets me 3. I wonder how I can make x minus 5 equal 1.1. I think 6.1 gets the job done. So if I put 6.1 in here, minus 5, I get 1.1, which is 3 approximately, times 4, a jump of 12. On top of 6, 18. We's done. I'm going to upload this as quickly as I can. Happy 4th.